Hello everyone, we are team the PRISM and I will demonstrate to you on our problem statement, which is AI based rockfall prediction system and alert system for open pit mines. Our theme is disaster management and we are working for Ministry of Mines. So the layers involved in our project are: first is the data acquisition layer, the second is the IoT hexapod or the drone roles, the third is the processing, which involves the 3D modeling development and the digital twin. The fourth is the middleware layer where we use the data streams to update the digital twin, and the fifth is the analytics and modeling layer. The sixth is the simulation layer where we experiment the simulations, or we use what if situations to future predict what can happen. And fifth, the finally is the alert system, which involves both web app and the mobile apps. And finally, I will talk about the integrations with the external systems using our inbuilt APIs and the future goals. So let's start with the first, the data acquisition layer. We collect the digital elevation models in the raster form from SRTM 30 meter and Copernicus Glow 30 meter, and we also collect the InSAR Sentinel-1 SAR data from Google Earth Engine. We will also collecting thermal images using UAV and LiDAR, and using all of this we are going into the processing, which is the 3D modeling and base twin layer, where we make 3D meshes of the digital elevation models, use libraries like Rasterio, NumPy, TriMesh from Python, and QGIS for mesh export, and we use various tools like Blender and Unreal Engine to make a realistic view of with elevation supported from DEMs to give further improvement to the images meshes formed. And finally, we do the visualizations using PRISM.js and WebGL in our own dashboard. This is the hexapod that we have built, and it has various sensors integrated into it, like temperature, pressure, humidity, and tilt meter, accelerometer, and gyro. And you can see the FPV view of the hexapod moving. And this is our drone captured imagery, or popularly known as UAV, unmanned aerial vehicle photogrammetry. It will capture high frequency orthophotos, cliffs face imagery, texture, rock joint mapping, which will be later used for 3D construction and surface change detection. The third is the middleware layer, where we take data inputs from various sources like IoT devices, which includes Hexapod and the drone. The message bus, which is the we use as Apache Kafka, handles large streams of data. Fourth is the analytics or modeling layer, where we use PINN, which stands for physically informed neural networks. We are working on equations like Richard's equation plus Van Gogh closure equation, where we take those parameters, evaluate from the IoT sensor and historical data to train the ML models and on the digital elevation models, and then the nodes which are on the digital twin are significantly dependent on those factors. Next, we have the simulation or what if situations. We just some situations which are given by the user to tweak those nodes in the digital twin, and then through that we predict the future outcome of what may happen, given let's say for example a blast event may happen, seismic event may happen, or there is a huge amount of rainfall. Then what are the changes, topographical changes that may happen in the digital twin? We can represent it. Finally comes the alert system in the user app. If the threshold is crossed for given based on the risk score by a system, then we alert the user and through in-app notification, SMS, and email. This is our web app, and this is the landing page of a web app. Let's quickly just log in. We are in admin mode, so yeah. So this is our home page, and then I'll show you the dashboard. The dashboard has a Mapbox integration, so you can see this is just an example of a tile where we see the sensors that deployed by us in the map. Yes. So the user then selects rectangular figures out of this, and then they use to make the DEMs, the digital elevation models, out of this. Next, we have the data input page, where the user can upload the data sets. The data input page, where the users can import files and the data sets and do pre-processing on them. Yeah. So next comes the rockfall prediction Rockfall prediction system, where we choose the model selection, and then a simple ML model will do work, and then based on the parameters and training configuration, we apply the training, and we get the results from this. Next, we have the analysis page, where we get the advanced analytics out of the prediction that we have made. Same goes for reports, and then let me just quickly show you the digital twin. Yeah, so digital twin model works like a 3D simulation of the terrain, and then it will simulate the changes, land changes, and it will predict the risks based on those changes made. If the risk level goes high, we see a red color, and if the risk level is low, we see a green color. Finally, we have the alerts page, the sensor management page. The sensor management page fetches the real-time data from the IoT devices. We have parameters like temperature, humidity, atmospheric pressure, accelerometer, gyro, orientation angle, and speed. Then we have the alerts page and notification page. If we just acknowledge this, so it will send me an email. Here you see the urgent email message has been received by me. This is a mobile app. You can see it has an inbuilt sensor map which locates the sensors that we have, and we can also see our location. Yeah, so and then we have an alert section which alerts us about the disasters happening around us. Then we have the sensors page, which shows the sensors for monitoring them, and we also have a profile section. Finally, we have reached our conclusion. So it seems, talking about the integrations with external systems, we will be building APIs that connect with the external systems like water management, like SCADA systems. Then we have the blast systems like Orica Plus, and then like something like the fleet management systems, etc. And talking about the future goals that we can implement is that we can implement the alert system in the software defined vehicles like Tesla. They will have the alert systems whenever they will be the SDVs will be going through the risk prone rockfall zones, and the alerts, or you can build sirens along the roadways to sound the alarms whenever there is a high chance predicted by our systems. So yeah, that's for all, and this is for us. This is team Prism. Thank you.